A equals 11, B equals 9, and C equals 4, what is A plus B squared plus plus C? Could you calculate that for us, please?
$96.
96. All right, so your answer is 96 here. 11 plus 9 squared plus 4. That is 96. Very good. Okay, so that's pretty basic. No big deal there. Let's use the same numbers here. Refresh the screen here. Let's make the problem just a tiny bit more difficult. Let's go C minus 2A, like that. We'll just try that one there. Could you simplify that for us, please?
Negative 11.
Your answer is negative 11. Let's take a look here. 4 minus 2 times 11. So I do not agree with your answer. Did you put 4 in for C and 11 in for A?
Yeah.
Okay, so order of operations. What do you do first? Do you subtract or do you multiply?
Multiply.
Okay, what is 2 times 11?
22.
22. So we got 4 minus 22. What does that become?
Um, 18.
Nope. Try again. Here's what you said. Maybe that's not what you meant, but that is what I heard. So the sign comes from which number is larger? Is the 4, and really larger means further from 0. Is 4 further from 0 or negative 22 further from 0?
22 is further from 0.
So the answer must be negative. Then you take the larger number and subtract the smaller number, which is 18, but the answer is negative 18. Give me some feedback here, because I can't see your body language to know if that is clear. What's what is, because you gave me something that was very wrong, and then we worked through it, and there still seems to be something that isn't quite right here. So give me some feedback, please.
So what you do to calculate if it's negative or positive, you see which one's further.
Further from 0. Yep. So let's do some quick exercise here. All right, can you give me each of these results, please?
-4 for the first one.
Agreed. Keep going.
-10 for the second one.
So the second one is like the first one. You've got one positive on one negative. So you decide, well, which one is further from 0? That tells you the sign. -7 is further from 0 than 3. And then you take the larger and subtract the smaller without the sign.
So -4.
Yes. Okay, try the next one, please.
4.
It is 4. Keep going. So they're both negative. They're both negative. That means the answer is negative. Okay. When they're both negative, you add the numbers without the sign.
-10.
-10. Okay. So here, okay. So let me try to summarize because this should be clear. This should be a lot clearer. Okay. Same sign. Okay. So same sign is like 5 plus 4. See how they're both positive?
Yeah.
I mean, this is the most basic case. Okay. And there's only two cases, but same sign. If they're the same sign, you keep the sign. So you keep it, and then you add the numbers without the sign. Okay, now you know this is 9, but this is why. It's because they're both positive. It remains positive, and then you just add the numbers. But they could also be both negative. Do you agree that these are both negative?
Yeah.
Okay, they're both negative, so you keep the sign. Then you add the numbers without the sign.
Okay.
Okay, so that's same sign. There's only two possibilities. They're both positive or both negative. In both cases, you keep the sign, you add the numbers. Then there's the other case, which is they are opposite in sign. Okay, meaning one positive, one negative. Okay, so let's look at the basic example here. 7 minus 4. Okay, the 7 is positive, the 4 is negative. Okay, the sign comes from whichever one is further from 0. So in this case, it's positive because the 7 is further from 0. And then you always take the larger and subtract the smaller, but without the sign. Now, in this example, it's kind of silly because you already know that 7 is bigger than 4. 7 minus 4 is 3. But I'm trying to show you why this is the case. Okay. And this is important because we're going to do this with variables here at some point in the next week or so. And it's got to be clear. Okay. Now, the other possibility is, well, what if it's -3 plus 7? Okay. So again, they're opposite in sign. One negative, one positive. Well, which is further from 0?
7.
7. So then you take the larger and subtract the smaller, but without the sign. So everything I'm doing in this column right here is without the sign or the signs. Okay. You either add them because they're same sign, or you take the large and subtract the smaller. And this is obviously positive 4. Now it works when we're going the other direction. Like let's say it's a 5 minus 8. Okay, which is further from 0, 5 or the -8? Well, it's the -8. That tells you that it's negative. Okay, then you take the larger and subtract the smaller without the signs.
Okay.
So this is now -3. All right, so
Okay.
then let's try another one here. Let's say it's -9 plus 5. Okay, which is further from 0, -9 or +5?
-9.
-9. So we know the answer is negative. Then you take the larger and subtract the smaller. Okay, so just to summarize here, there are only two cases. Either the numbers are both same sign or they are opposite in sign. Now within the cases, there are different examples. Like if they're same sign, they could be both positive or both negative, but it's the same strategy. You keep the sign and add without the signs. If they are opposite in signs, you figure out the sign by determining which one is further from 0. Okay. And then you take the larger and subtract the smaller.
Okay.
Now, you are not the only math student that has not figured this out up to this point. And my goal is to get you to figure it out. And we have plenty of time to do that. Okay, so I'm going to give you a few practice problems now. We'll just revisit it. But don't be discouraged because you do need to get this down. Do you have any questions before I ask you to do a few problems here?
No.
Okay. So I'm going to throw some problems at you. Okay. You got to get them all right before we can proceed. So give me your answers and we'll take a look at some point.
First one is -3.
All right.
Second one is -8.
Okay.
Fourth one is 1. Last one is 2.
Good. These are all correct. Okay. So I'm gonna periodically throw these at you just to see where you're at. But good job on that one. So going back to kind of where we were starting here, I'm gonna grab these again. I want to give you one more order of operations problem to think about here. Let's go 2 times b minus a cubed plus c squared. Okay. So give this a try, please.
$80.
All right, so your answer is 80. Let's take a look here. 2 times 9 minus 11 to the power of 3 plus 4 squared. Now, I probably should be substituting these in parentheses like we talked about. What do you do first here? You got multiplication by 2. You got stuff inside parentheses, subtraction. You got a power of 3. You got an addition. What did you do first here?
9 minus 11.
Okay, what does that become?
2.
Nope.
-2.
Yes. Okay. All right. Now, try to do one thing at a time here. What is minus 2 to the power of 3? And this could be new, but give me some feedback. 2 negative 2 to the power of 3.
-8.
It is negative 8. Good. And then you're multiplying by 2 and adding 4 squared. What is 4 squared?
16.
16. Good. All right. What is 2 times negative 8?
-16.
Good. Plus 16.
0.
2 to 0. All right. Okay, let's try another one here. All right, let's go negative a minus b over c. Let's keep it really, really straightforward. Why don't you try this one, please?
-5.
Is that your final answer?
Yep.
Good. Okay, so minus 11 minus 9 over 4. We talked about there being implied parentheses in the numerator. Minus 20 over 4 is minus 5. Very good. All right. So this topic will come back. We're going to move to, just double check here what I had us moving to. Done a little bit of that. A little bit of that. Okay. Yeah, that might be good for some homework. All right. So where we're going to move from here is let's talk about solving equations. Okay, this is kind of your next major topic in this class. So none of the problems that we've been doing thus far have had an equal sign. Like there's no equal sign here. There was no equal sign here. The variables had equal signs. They're assigned a value, but there's been no formal equations. These have all been what are called expressions. So first thing is that equations have an equal sign in them. Expressions do not. Okay. So the most basic type of equation we can solve is what's called a one-step equation. A one-step equation means you're solving it with addition, subtraction, multiplication, or division. The division is usually shown as a fraction bar. All right. So just to see if you understand this, because this is something you probably have already seen, I'm just going to throw out 4 problems again and see if you know how to solve them. Let's go. X divided by 3 equals -2. Minus 4 equals 3 plus x. 5x equals -20. And then x minus 3 equals -3. All right, so I'd like you to try solving each of these 4 equations. They're all one-step equations, but it'll help me to gauge your understanding. So go ahead and work those out for me.
First one is x equals -5.
Okay, keep going.
Second one is x equals 7. Fourth one is x equals -25. Last one is x equals 0.
All right, so only one of these are correct. This is the only one that's correct. So I'm gonna give you one more chance here to make some changes. Just because I don't want to jump to conclusions here quite yet. Take a look at those other ones. Or you can say, hey, Matthew, like, I don't remember any of this. I have no idea. And that's okay too. I'm just trying to gauge where you're at.
Is the first one x equals 5?
All right. Yeah, no, we're off on there. So let's talk about this because it may be like one of those things where like once I show you a few examples, you're like, oh yeah, I got it. You just need a little reminder. Okay. So there's some simple things in math. You undo addition with subtraction. You undo subtraction with addition. You undo multiplication with division. You undo division with multiplication. So I want you to stare at this and just sort of tell me if you see the pattern. Do you see the operators that are related?
Yeah.
Addition and subtraction operators are related. So let's look at the first two. All right, let's say I give you x minus 4 equals -2. Okay, you look at the side with the variable. The side with variable. That's another thing is you looked at the side with the variable. You actually don't care what's going on with the other side, but you look at the side of the variable and you say, what's going on here? Is this addition or subtraction? Like, and you say, okay, well, it's subtraction. How do you undo subtraction?
With addition?
Addition. Now, the way this works when you solve, we have sides. We have sides of the equation. We have the left side and we have the right side. Okay. So whenever you do something to one side, like adding, you have to do it to the other side. That's what makes this work. Okay. The thing that you're undoing when you take subtraction by 4 and add 4, when you undo it, notice I said undo. I didn't say like anything else. I just said the word undo. It's gone. It's eliminated. So it's just the variable. And now you have to be able to take these two numbers and combine them, which is that stuff we were working on earlier. -2 plus 4. Can you tell me what that is?
2.
It is 2. Okay. Now, there's lots of variations of this. Like I can put -4 equals 3 plus x. Okay. Lots of variations in this. So now this time the variable's on the right. So your focus is now on the right side. So how do you undo the 3? And first of all, the question is, well, is the 3 added or subtracted? Well, there's really a plus in front of the 3. It's just not written. So how do we undo addition with
Subtraction.
subtraction? So you're going to subtract 3 from both sides of the equation. Now on the side that you started on, it undoes it. It's gone. Okay. All right. Now on the left side, you got to be able to do this arithmetic. You got to be able to say, okay, what's two negatives here? -4 minus 3 is, I'll wait for you to give me.
-7.
Yes. Very good. Okay. All right. So in both of these problems I've given you, you undo addition with subtraction, you undo subtraction with addition. Any questions before I give you a few practice problems here to try?
No.
Okay. So let's try this. Let's go -4 equals x minus 2. X plus 3 equals -3. -4 plus x equals -8. X minus 2 equals -2. All right, so why don't you try solving some of these and let me know what you come up with.
First one is x equals 0. Second one is x equals -6. Fourth one is x equals -4. Last one is x equals -4.
Like this?
Yes.
Take a look at my screen. Take a look, because all I did was write down what you said. I didn't make a comment whether you're right or wrong. Are these your answers?
Yes.
Okay, so let's take a look here. In the first one, you have subtraction by 2. So how do you undo subtraction by 2?
Addition.
Add 2. Now, in my world, there's no way that -4 plus 2 is 0. What should that be?
-2.
-2. Okay. Let's look at the next one here. Adding 3. You look the side with the variable. You're adding 3. So you subtract 3 from both sides. And yes, that is -6. Good. Next one here, you're adding 4. Adding 4. That is -4. Now the last one, -2. Okay. You're adding 2. What should the answer be? It's not -4.
0.
It should be 0. Okay. Any questions on that or thoughts?
No, I just put for the last one the wrong signs.
Do you mean you wrote it down wrong, or you just you wrote the wrong thing when you were solving it?
Wrote down the wrong. I put a -2 instead of a positive.
Okay. All right. It's just right because it's because you're going through a screen and you're copying stuff down. Like I would understand, hey, I just didn't write it down correctly. But if you had solved it wrong after writing it down correctly, that's what my concern would be. So okay, let's talk about multiplication division problems now. Okay. So again, like if I give you something like x divided by 2 equals -3, okay, you undo division with multiplication. Okay, and you multiply by the number that's on the bottom here. So you're going to solve this. You multiply both sides by 2. Now on the left, these cancel. They undo each other. So the left becomes just x equals, the right side is minus 6. Is that okay?
Yes.
All right. Now there are other ways to solve this. There's cross multiplying. There's lots of variations of this, but this is just one of them. So if you don't like this, I'll give you another way. But it could be that you have x. All right, let me do it differently. You have 5 equals x over 3. It could be on the other side there. So you undo division with multiplication. Here you multiply both sides by 3. Okay. And so the answer is 15 equals x. And you correctly told me all these times as the variable first. You want to put the variable first. Is that okay?
Yes.
All right. Now it could also be that you could have negative numbers. You could have like x over -2 equals 8. So in that case, you still multiply both sides by whatever number is on the bottom, and they cancel.
Okay.
All right, so you undo division with multiplication. And now we're going to look at problems where you undo multiplication with division. So it's a new set of examples here. Let's say it's like 5x equals 15. On the side with the variable, you're multiplying by 5. So you undo multiplication with division by 5. Again, your focus is always on the side with the variable.
Okay.
Now, I could also give you an example where it's minus 3x equals negative 18. The -3 is multiplying x. So you undo multiplication with division.
Division.
You divide by whatever number is in front of x. If it's a positive number, you divide by positive. If it's a negative, you divide by negative. So x equals 6 on the right. All right.
Yep.
Now there's a small little wrinkle here, which is like, what if I write something like this, like negative x equals 4? Okay. This negative in front of the x really means -1 times x equals 4. And you undo multiplication by -1 with division by -1. So the negative in front of the x, it's still a problem. Like it is not solved for x. You have to get it to just x equals -4 in this case. Any questions on anything I've just said before I give you some problems to try?
No.
Okay, let's take a look here. So here are 4 problems to try. Let me know if you have any questions, but do the best you can to work those out, please.
First one is x equals negative 64.
Okay.
Second one is x equals negative 7. Third one is x equals 1. Fourth one is x equals negative 5.
All right, all correct. Well done. Okay, so I want to give you just a few more of these mixed up, of course. That's really the challenge here, is to be able to solve them when yeah, they're all mixed in together. Let me have you try. All right, so throw a couple more at you. I'll put these two in front of you, and then I'll put these in front of you here. All right, so go ahead and work these out, please.
First one is v equals negative 12.
Okay.
Second one, b equals 108. Third one is n equals negative 7.
Okay.
Fourth one is n equals 30.
Okay. So the two on the bottom here are not correct. Why don't you take one more look at both of those, please? Always good to think about, like, you know, the operations, maybe even writing them down so you know what you're going to do to undo them. So let's try these both again, please. Like on the left here, it's division. So you undo division with multiplication.
Okay.
And you multiply by the number on the bottom. You're really close on the first one here. Number 13. What, you have a new answer for me?
No, but I did 14.
Okay, what is 14?
N equals 4.
Yes. Now, you're multiplying both sides by 18. Okay. Is your answer positive or negative?
Positive.
So you have a positive times negative. So positive times a negative or a negative times a positive always produces a negative. Whereas a positive times a positive, negative times a negative, that produces a positive. So this is yet again one of those like things, you know, just you got to get down somehow. You got to spend some time here to figure out how you're going to remember these, you know, flashcards, Quizlets, whatever. You got to find a way.
Okay.
All right, so let's try this again here. You got positive times a negative. The answer is negative 108. All right, so what I'm going to do here is I'm going to snip in your homework here. Snip it in here at the end of the lesson. So that way you've got a reason now to open up the lesson notes here at the end. This should not take you again more than 10, 15 minutes. Like my goal isn't to wear you out with problems. It's just to get you to do something between the times we meet, because we're not meeting again until next Tuesday. And you know, the weekend's in there, but I would just set aside 20 minutes and work out, you know, whatever you can on these. I'll do the same thing next time. I'll ask you if you have any questions, and we'll look at them. All right, so we're gonna go ahead and stop there for today.